Wow, every morning 8.5 million people wake up in New York City. But the Big Apple doesn't belong only to humans. This is the city of ants. There are 17 billion of them here. They live in houses, hide in the grass, crawl under asphalt, and climb trees. For every New Yorker, there's a sneaker box filled with ants. City ants are more fortunate than their forest cousins. They don't have any need to look for food. Millions of people leave behind tons of hot dog crumbs, pizza slices, and coffee drips. Insects just have to wait for a lunch break in an office building. Then they gather around benches in the park or cafe tables. A lot of food is waiting for them there. Over 1 billion. That's how many ants are running through the streets and parks of Manhattan. And in this ocean of insects, scientists have been able to spot tiny reddish-brown creatures. These insects don't fit into any of the 13,000 ant species known to science. They're unique and only live in Manhattan. Their kingdom is between 63rd and 76th Streets. Scientists don't know how long the Manhattans have evolved in isolation. They arrived in the U.S. on ships from Europe and were cut off from the rest of the city's infrastructure. But why go anywhere else if there's enough food? The Manhattan loves fast food, especially corn syrup. Because of such a diet, the insect's body has an increased carbon content. This isn't a problem for the ant, though. Carbon helps it adapt to the dry, warm weather of the concrete jungle. Around 20% of New York City is parks and green spaces. White-footed mice live in these places. Scientists have found out that the mice that live in New York have evolved. They're different from their village relatives. These changes are genetical. It's caused by the diet of white-footed rodents that feed on human food waste. For example, New York mice need enlarged livers to process fatty acids from fast food. Central Park in New York is almost twice the size of the Principality of Monaco. A unique centipede is only found in this green area. The creature, called Hoffman's dwarf centipede, doesn't grow any longer than 0.4 inches. It lives in heaps of dry plants and runs on 41 pairs of legs. This crustacean, measuring only a bit more than 0.3 inches, is called the Socorro isopod. It's one of the rarest animals on the planet. The creature can only be found in a small thermal spring near Socorro, New Mexico. The isopod lives in the water as warm as 90 degrees Fahrenheit and covered with a layer of algae. These are ideal conditions for the creature. To get to Mobile Cave, you'd have to rappel 65 feet down. That's the height of a 4-story building. After that, you'd crawl through narrow passages and swim along a canal with cold water. Sunlight can't get into the cave. The air is poisoned by vapors of ammonia and hydrogen sulfide. This extreme place has been isolated from the outside world for 5.5 million years. A unique ecosystem has formed in this toxic atmosphere. Of all the animals that live there, 33 species of millipedes, scorpions, spiders, and leeches can't be found anywhere else on Earth. These creatures are mostly blind and colorless. Well, why would you need eyes and disguise if you live in complete darkness? Mobile's coolest guy is the venomous centipede. Scientists have nicknamed this animal the King of the Cave. It doesn't grow more than 2 inches, but for this world, it's a giant. The blind salamander would feel great in the company of strange animals from Mobile, but these little monsters are separated by the ocean and thousands of miles. The Mobile Cave is located in Romania, where these beauties live only in Texas. Their home is an underground body of water in the San Marcos area. These salamanders grow to be 5 inches long. The name makes it pretty clear that the animal is blind. It does have eyes, but they're pretty much useless. This doesn't stop the salamander from being a skilled snail and shrimp hunter. It senses other animals by feeling the underwater waves they create while moving. The Scottish wildcat lives in the north of Scotland. This animal is different from domestic cats, which love sleeping on the couch. Unlike them, it's a perfect hunter. The creature is 25% larger than the average cat. It's muscular and long-legged. The wildcat's tail is blunt and fluffy, covered in black rings with a black tip on the end. The quokka is called the world's happiest animal. Just look at its smile. This fluffy animal seems to always be ready for a photo shoot. Quokkas are only found in Australia. Around 10,000 animals live on Rottnest Island and several other locations. The creature's cute smile is an evolutionary trait. An open mouth helps it breathe and regulates its body temperature. Oh, by the way, if you try to feed a quokka, you'll have to pay a fine of more than $200. This baby will feel comfortable even if you put it on your little finger. The animal lives only on the island of Madagascar. Scientists have found just 2 tiny reptiles, a male and a female. The researchers have named the nano-chameleon Brookesia nana. It's a mystery to them why it doesn't grow larger than a sunflower seed. The next animal on the list also lives only in Madagascar. Locals call this creature Ai. The unusual lemur spends most of its life in trees and leads a nocturnal lifestyle. This might explain why it looks so tired. Even though the Ai is a lemur, its teeth are like those of a rodent. Its claws resemble sloth's claws, and its body looks like that of a monkey. The animal's fingers and toes are especially frightening. They're long and thin, with pointy claws. Get equipped for any season with brand new Brightside merch. Click the link and grab your print. This is a giraffe with its trademark long neck. A zebra is grazing nearby. Black and white stripes on its body help the animal reflect sunlight during the day and keep it warm at night. But what if you combine these animals? No need, nature has done this work for you. The okapi looks like a giraffe with a short neck, horse body, and zebra stripes on its legs. The okapi has a long tongue. Males have small giraffe horns on their heads. You can only meet these unusual animals in the African rainforest. If you decide to travel around Africa afterward, you must visit the Ethiopian highlands. That's where you see unique gelada monkeys. And no, they're not named after the Italian ice cream. That's gelato. Don't mix that up. Males look like rock stars from the 70s. They're bright and have cool hair. But don't mess with these animals. They aren't too friendly. Geladas spend most of their time on the ground, and the main part of their diet is the grass they collect during the day. Scientists believe that geladas are the remaining members of an ancient gang of critters. It lived millions of years ago in vast spaces from South Africa to India. Now, imagine people the size of the Statue of Liberty living next to us. Sounds like science fiction. But for the animal world, this is reality. The world's smallest tortoise species, the speckled tortoise, doesn't grow more than 4 inches long. But the Galapagos Islands are home to giant tortoises that reach the length of 5 feet. They also weigh like a sports bike. The largest of them had an incredible weight of 1,000 pounds. The giant Galapagos tortoise lives for 100 years and sleeps 16 hours a day. Due to its slow metabolism, the animal may not eat or drink water for a whole year. Millions of years ago, lizards from South America climbed onto a log. Sea waves carried the log to the Pacific Ocean. The lizards traveled hundreds of miles and ended up on the Galapagos Islands. They had to evolve to adapt to new conditions. Scientists believe this is how the marine iguanas appeared. These unique animals look like dangerous dragons, but in fact, they feed on plants and are totally harmless. Iguanas spend most of their lives in water. To get rid of sea salt that accumulates in the body, these animals literally sneeze salt. Achoo! The lyrebird lives only in southeastern Australia and the island of Tasmania. The bird has such a strange name because of its tail. It looks like a lyre, a stringed instrument of the ancient Greeks. Lyrebirds are known for their ability to imitate other birds, and not only them. The bird copies animal screams, human voices, chainsaw noises, car and fire alarms, and even the click of a camera. About 12,000 years ago, a salt lake appeared on one of Palau's islands. Today, it's called Jellyfish Lake. This 1,500 by 500-foot reservoir is home to 5 million golden jellyfish. These unique creatures swim to the west shore of the lake every morning. There, jellyfish wait for the sunrise. Then, all day long, they follow the sun. Algae lives in the tissues of the jellyfish, feeding them with energy. These algae can't live without sunlight.
Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalts. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence?
The speed of light is the fastest thing in our universe. It travels across space, passing through Mercury and Venus to reach us, and it's slowing down. No need to panic though. The sun is getting weaker, but we won't see the effects of it for another billion years. In the vacuum of space, the speed of light is around 186,280 miles per second. Any slower than that, and humans would see the changes firsthand. There would be some awesome effects, like colors changing and the brightness of objects fading. We'd also notice some differences in everyday objects, their length and shape. Scientists created a simulation to see what would happen if the speed of light was slower. In a vacuum, the speed of light can't change, but if light passes through different materials and objects, it alters the way we perceive things. Light acts as a wave and a particle, meaning that it's a wavelength. The color and frequency are determined by the distance from crest to crest in the wave. It behaves similar to sound with the Doppler effect. Imagine you're standing in the middle of a busy highway and a honking car speeds through. Wow, that was loud. You can hear that whoosh-like sound of the horn because the moving object produces the sound while you're stationary. The frequency and pitch seem to change, but it's just the sound reaching your ear faster than it would if you and the car were both stationary. Light behaves similarly. The wavelengths change if the speed changes. Moving toward a light source and making the wavelength shorter will shift the color to a blue and violet hue. Moving away from the light source, and you'll get something more reddish. So if the speed of light slowed down to walking speed, we'd notice the colors changing when we approach an illuminated object. At the same time, the color would change around us and behind us. If you walk sideways, the colors you're walking toward would become bluer, and everything in the distance would become red. This information is useful to astronomers who are studying objects in space. If they're blue shifted, that means the object is moving towards us. And if it's red shifted, then it's going in the opposite direction. In fact, everything in the universe is red shifted, proving that the universe is expanding and getting further away from us. The slower it gets, the brighter it becomes. That's because the photons become more present for us to see. At this rate, we can see invisible light and increased intensity. You won't notice that effect much if you're standing still, but because of the Doppler effect, moving towards an object will have different colors and different light intensities. Another phenomenon we'd experience is time dilation. It's when you move at a similar speed as light and time decreases relative to someone who isn't. Space and time are relative. So if you're sitting at your desk wasting hours away, yeah, sounds familiar, doesn't it? All your movement will go through time and not through space. You're stationary, but you're still technically moving forward in time, slowly aging. The faster you move through space, the slower your movement through time will be. If you move at the same speed as light, then all your movement will be through space and not through time. To notice that, you'd need another person to watch you. You're not in a time machine. You're both on Earth experiencing the same time flow. To you, experiencing this firsthand makes it feel like you're going faster, because you're getting a lot more movement in space in a given time. The closer you get to the speed of light, the smaller you become. Well, not really, but it depends on who's watching. If you're the one traveling at such a speed, an object nearby will seem small, just as someone who's watching you travel at the speed of light will think that you're smaller than you actually are. The simulation that the MIT scientists conducted showed that if the speed of light drops, everything will become stretched out like a pancake. If you see mountains in the distance and then run at the speed of light, they will appear further away. Objects will become distorted, and it will feel like you're getting to a certain place faster because time has slowed down for you. If you're standing completely still and someone standing on your left-hand side throws a cube-shaped object over to your right-hand side, then naturally, you'll see one side of it unless it flips around. But in this new reality, you'll get to see the front side wrapping around the visible side you're seeing. If you're moving at the same speed as light in an infinite space, everything will be stretched out as you reach infinite speeds. In a world where people can walk at the same speed as light, we'll perceive nothing as normal. We'll have to get used to the way we see objects. Every movement we make will result in drastic shifts of colors. Even turning your head to look at something will feel weird. Let's say you're in a supermarket buying groceries, and you walk from aisle to aisle. The milk at the end of the counter will look like it's really close to you. But when you approach it, you'll start to feel like it's getting further away from you. The milk will also look a bit red. As soon as you get closer to it, it will shift to blue. If someone is passing through with a shopping cart, you'll see it as a sort of 3D model of a shopping cart. The color will shift as it gets further away from you. It will appear far away, but it's right in front of you. In fact, we don't really know the actual speed of light. Physicists gave it roughly 186,280 miles per second, but that constant is just for them to calculate other scientific stuff so we can understand it better. The problem is that we can only measure light with light beams and mirrors. But it's not like all we have to do is point a light beam at a mirror and measure its original path and its reflected path. Einstein's theory of relativity states that the original path of light moving from the source to the mirror may not be the same speed as the reflected light from the mirror back to the source. Hypothetically, if it takes light 10 seconds to travel from the source to the mirror and then back to the source, then we can conclude that each trip takes 5 seconds. But Einstein's theory is that it could take 9 seconds for light to travel from the source to the mirror and only 1 second from the mirror back to the source. Or vice versa. Or maybe completely different numbers altogether. That's why it's so difficult to measure light. A breakthrough came out for scientists when they managed to slow down the speed of light to 0 without losing its brightness. They did this by using ultra-cold atom clouds made with photonic crystals. These crystals are materials punctured with billions of tiny holes where light can refract. But what if we lived in a world where light stopped halfway? You'd wake up one morning and feel like it's twilight. You'd open the curtains and see that many car lights are on, but aren't so bright. You turn on the lights in your room, but feel like the bulb is tapping out. You replace it with another one, but it doesn't do the trick. You turn on the lights everywhere in your house, but it's all just giving weak light. You're confused and try to check if there's a problem with the electricity in your house, but it seems to be working well. You check on your neighbors, and they also have the same problems. Even experts in the field can't understand what's going on. Hours pass, and it's all the same. All the light in the world seems to have frozen halfway. Your phone is low on brightness, even though you bumped it up to maximum. Everything is getting darker. You learn from the news that it's a global problem. Light is slowly diminishing, and soon there won't be any of it in the world. You decide to wait it out while everyone else is panicking.
The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international dateline, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal, but a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years. And it does show. See for yourself. Due to such a long isolation, the conditions inside the Mobile Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say, thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. 2 miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super-tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7 feet wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long, long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
The problem with that asteroid that destroyed dinosaurs was not that it fell, but where it fell. This colossal space rock found the worst place where it could land. Also, the angle at which it hit the ground was the most unfortunate. If it had fallen vertically, there would have been less destruction. But it fell at such an angle that it threw a huge amount of dust into the air. After the disaster occurred, tons of soot started burning. 65 million years ago, only 13% of Earth's surface contained the right amount of sulfur and oil needed to form a colossal amount of soot. If the asteroid had fallen on the other 87% of the territory, dinosaurs could still be living today, but it hit the worst place and lifted 1 million tons of burning material into the sky. A cloud of incandescent particles covered the sky and set off on a journey across the mainland. Then, these particles settled on the ground and caused large-scale fires. Trees were burning and sending more soot into the sky. But the asteroid collided not only with rocks, it fell on the coast in a place where the seabed was filled with sulfate. As a result of the collision, it started burning, which caused the release of sulfuric acid into the atmosphere. The air became poisoned. It seems the dinosaurs didn't stand a chance. And now, let's imagine the asteroid falling in another place, somewhere in the middle of the ocean. Huge waves flooded part of the land, but almost all kinds of dinosaurs survived. Or even better, the rock could have fallen somewhere in the desert and left behind a giant crater. That's all. Yes, several dinosaurs passing by wouldn't have survived the collision, but the situation wouldn't have been so critical in general. So, giant lizards remain dominant on our planet. They don't allow other animals to develop since Tyrannosaurus and other ferocious reptiles hunt mammoths and other ancient creatures. The population of mammals is decreasing. Velociraptors are fighting for territories with saber-toothed tigers and giant bears. A struggle for survival between dinosaurs and other animals begins. Then, the Ice Age comes, and some reptiles don't survive. Then, new players enter the field. Those are humans' early ancestors. Living side by side with dinosaurs is difficult. Lizards attack settlements and caves, so people have to build high walls for protection. By the way, the Tyrannosaurus poses less danger to people than you might have thought. According to the latest research, many creatures were able to run away from this monster. Yes, you probably saw how easily they caught up with cars in the movies, but it wouldn't be as scary in reality. Paleontologists and biologists have analyzed the strength of dinos' bones and found out that the creature couldn't reach high speeds. The maximum it was capable of was running twice as slow as a field athlete. Thousands of years have passed. People have learned to live with dinosaurs. They've even managed to tame some lizards. They've domesticated herbivorous dinosaurs to develop agriculture. Triceratopses and bulls now plow fields together. Imagine farms swarming with diplodocus or brachiosauruses. People climb their long necks and pick fruit from high trees. Stegosauruses protect pastures from wolves and velociraptors. Dinosaurs with shells, such as ankylosauruses, help people cross deserts. They, along with camels and donkeys, carry heavy loads. People share the planet with ancient lizards and live in harmony. The situation in the seas and oceans is much worse. Sea reptiles attack wooden ships and catch all the fish. Imagine that you're sailing to another continent with tons of grain, fabrics, fur, and other goods. And then a giant mosasaur appears on the horizon. It's one of the most powerful sea lizards. A great white shark looks like a small fish next to it. The creature could easily defeat a megalodon. And then it comes across a wooden ship. It bites into the deck and pulls the whole boat underwater. Water dinosaurs are the main obstacle to communication between countries. This slows the progress down for 100 years. People built metal ships to withstand the attacks of the mosasaur. And finally, they managed to establish sea connections. A similar problem occurs when the first planes take off into the sky. Imagine you're flying on a passenger Boeing. You look out of the window and see a pterodactyl. Wait, it's impossible. These winged lizards aren't so fast, but they can catch up with a helicopter or some old biplanes. This poses a serious threat to flights, so people install sound protection systems on board each aircraft. Pterodactyls hear irritating ultrasound from a distance and fly as far away from it as possible. People equip submarines and ships with the same sound shields. Then, after people have learned how to defend themselves from dinosaurs, another problem appears. Lizards are the kings of wildlife, so they displace all other animal species. Dinosaurs run across African savannas, and lizards with fur live in cold winter forests. Lions, wolves, and bears are not the rulers of the wild. Rhinos fight with Parasaurolophuses. Stegosauruses attack hippos and take away their territories. Venomous dinosaurs live in jungles. Lizards that can climb trees scare monkeys. Imagine a reptilian ape jumping from one branch to another. To save regular animals from extinction, people have to control the population of predatory reptiles. Huge parks and nature reserves appear in all countries. People transport dinosaurs there and separate them from other wildlife. Dinosaurs seem to be completely under control. When the danger caused by giant reptiles passes, people begin to breed smaller, harmless lizards. Someone buys a chameleon, and someone keeps a Microceratus at home. There are dinosaur exhibitions. People take these creatures for a walk as if they were dogs. Some people take selfies with reptiles, go shopping, and sit in cafes with small lizards. Dinosaurs aren't formidable now. They're kinda cute. People ride horses, camels, Parasaurolophuses, and Pachycephalosauruses. Of course, many have tried to tame velociraptors, but failed. Those are dangerous reptiles and they don't know how to obey. Taming them is almost as difficult as taming an alligator. But dogs and cats are still more popular because they're more intelligent. The brain of a dinosaur is almost the same as that of a chicken. But who knows, if they had lived to this day, perhaps they would have evolved into smarter creatures. Just imagine if dinos were intelligent. In this case, people would have a big problem. Some scientists think that even if a meteorite hadn't destroyed the dinosaurs, they wouldn't have survived to this day. They needed to carry their own colossal weight at all times. It was an enormous load on their bones and joints. Most dinosaurs wouldn't have been able to survive the Ice Age with such characteristics, but smaller lizards might have succeeded. Fast and agile dinosaurs, such as velociraptors and Pachycephalosauruses, would have survived, but in what form? Could dinosaurs have already evolved into something else? Look at the good old chicken. Many scientists believe it's a direct descendant of the formidable Tyrannosaurus. Somewhere deep inside the bird's DNA, there are genes that the dinosaur had. Yep, it's hard to believe, but look at the chicken's body structure and how it walks. Remove the plumage, cover the creature with scales, and give it toothy jaws instead of a beak. And now, you have a mini T-Rex in the coop. And by the way, not only chickens might be the relatives of giant lizards, many birds are dinosaurs' living descendants. Surprisingly, alligators, snakes, crocodiles, and monitor lizards are not as close to ancient reptiles as pelicans, storks, and other flying creatures. Over millions of years of evolution, the paws of dinosaurs turned into wings, and toothy elongated jaws ended up as beaks. The genetics of birds is the key to understanding dinosaurs. Pelicans are similar to pterodactyls, ostriches to velociraptors. Perhaps many other animals also share some genes with ancient lizards. If the meteorite hadn't fallen, all dinosaurs would have evolved into completely different, unusual creatures. Scientists want to carefully study the DNA of birds and try to reverse evolution with the help of genetic engineering. They hope to breed dinosaurs out of eggs one day. But to do this, they need to find a specific genome that hasn't changed over tens of millions of years. It hides in the DNA. And it's not so easy to find it and extract it. Do you think we will see powerful reptiles by 2050? Look at this spatula. Just a regular tool, mix and spread ingredients, right? But wait, this one is floating in space for some reason. So there's this astronaut named Pierce Sellers. There he is. He's up there in space, just doing his thing, when all of a sudden, he accidentally drops his trusty spatula. Let me give you some context. This all happened during the Space Shuttle Discovery's STS-121 flight back in 2006. They were on their way to the ISS on a mission to test out some new safety techniques. And now this spatula is just a tiny drop in the ocean of space debris. Humans have been exploring space for like over half a century now. We've left all kinds of random stuff up there, from itty-bitty bolts to entire space stations. We've chucked a ton of things into the great beyond. Most of it burns up in a spectacular blaze as it re-enters Earth's atmosphere. But some bigger pieces can be a real danger for astronauts and their fancy spacecraft. Like, imagine accidentally crashing into a massive hunk of space junk. There are other weird things found in space. In November 2008, astronaut Heidi Stefanishan Piper was out on a spacewalk trying to fix a jammed gear on a solar panel. Suddenly, she lost her grip on the bag. That bag weighed around 30 pounds and was filled with all sorts of cool stuff, like grease devices, a scraper tool, and bags for debris. And it was pretty pricey for a tool bag. It cost around $100,000. Sometime later, amateur astronomers spotted the bag floating around in space. If you're in North America, you can even check if the tool bag is passing through your little slice of the sky. Just hop on over to spaceweather.com's satellite tracker and see if you can catch a glimpse of this interstellar tool bag. By the way, if you need to twist some wires in space and you don't have pliers, well, you may stumble upon them as they're free-floating in space too. Back in the day, when astronauts were just getting their space groove on, they tended to misplace things up there. During his first spacewalk on the Gemini 4 flight in 1965, Ed White, a famous spacewalker, accidentally let go of his glove. That glove decided to have its own adventure and hung out in orbit for a whole month before getting roasted in Earth's atmosphere. So not all debris is there to stay after all. So, space junk is basically all the stuff floating around in space that humans have left behind. Before we got all curious and started exploring, there wasn't any space debris hanging around. Imagine space junk as a little kid who just learned how to walk and play with their own toys. When they couldn't walk yet, it was easy for the person watching them to keep the play area clean. They were in charge of taking out the toys and putting them away. But now that the kids can walk, they can grab as many toys as they want and make a huge mess on the carpet. Well, it's kind of the same with us humans exploring outer space. We've sent all sorts of cool gadgets, like cameras, rovers, and rockets to check out what's out there. But we haven't really thought about bringing them back to Earth. And that's where the problem comes in. All this space junk floating around could mess up outer space, and even our planet. When we think about outer space, we often imagine vast open spaces that are yet to be fully explored. Humans have only discovered a tiny 5% of the universe. But here's something they might not always consider: the impact of all the cool gadgets they send out there. Believe it or not, as of May 2022, we've got more than 5,000 satellites orbiting Earth. Over 5,000 opportunities for these machines to go haywire, get lost in space, or even worse, create a bunch of debris that could harm both outer space and our lovely planet. There's at least 3,000 satellites just hanging around up there, not doing anything useful, and nobody seems to be bothered about bringing them back home. And what if one of these inactive satellites accidentally collides with one of the thousands of other space junk pieces orbiting our planet? It will result in a catastrophic disaster. We're talking about a crazy release of toxic substances that could wreak havoc on our poor Earth. Space junk can mess things up for scientists trying to make important discoveries. It's not just floating around aimlessly in space or posing a threat to Earth. It can hinder their chances of success. Even the moon has its fair share of junk, which Neil Armstrong definitely didn't encounter when he landed there in 1969. Think of it like this. Imagine you're an artist trying to create a huge painting. It's hard to do that if there's a bunch of old paints, brushes, and other stuff cluttering up your play area, right? Well, it's the same deal for scientists trying to set up camp and use new technologies for advanced missions and space exploration. They need a clean and organized space, just like you need a tidy work area. Otherwise, it's chaos. So here's the deal with space junk. It's not just about sending stuff up into the atmosphere. It's also about how far away we send it. You see, when satellites are sent over 22,000 miles into the atmosphere, it becomes a real problem to retrieve them and bring them back to Earth. And that leads to even more space junk floating around up there. Now, I know what you're thinking. How long will it take for space junk to become a major problem? Well, it might still be a few more years before it messes things up in outer space. But hey, that doesn't mean it's not a threat to satellites we have up there right now. Those poor guys are at risk of getting damaged, destroyed, or even leaking toxic stuff because of all that junk. So, space debris isn't just a problem for space exploration, but it's also a problem for us Earthlings, even though it's floating thousands of miles above us. Space junk is like that annoying neighbor who throws trash out their window and it ends up in your backyard. Except instead of trash, it's releasing all sorts of chemicals into our atmosphere that are slowly destroying our precious ozone layer. It can even ruin future space missions. Imagine this. You're all pumped up to launch a rocket into space, but nope, space junk decides to crash the party. Not only does it mess up the launch, but it also adds more pollution to our already struggling atmosphere. And if things couldn't get worse, imagine a shooting star or meteor accidentally smacking into some space junk on its way to Earth. Boom! Millions of toxic particles raining down on us, further depleting the ozone layer. Plus, space debris is becoming a real problem for space missions. In 2022, we found some space debris hanging out on Mars. The Perseverance rover stumbled upon its own back shell just chilling on the surface of Jezero crater. They also spotted a random piece of a thermal blanket that might have come from the rover's descent stage. Also, human-made space debris actually smacked into the moon in 2022. It was probably some old rocket body from the 2014 Chang'e 5 T1 mission, but nobody saw that coming. It left a double crater behind. The more space junk we have floating around in low Earth orbit, the higher the chances of a cosmic collision. These collisions are no joke. They've already caused some serious satellite damage. Even the ISS has to constantly maneuver to dodge space debris. But scientists seem to know how to clean up this orbital mess. They're planning to send space vehicles armed with nets, harpoons, and even robotic arms to capture and deorbit all that junk.
You're in the middle of the Sahara. You see a huge awning with a red target pattern. Its surface is so hot you could fry food on it. A drop of water is to hit the center of this target at the speed of light. Theoretically and technically, this experiment is impossible to conduct. But if it happens, then mysterious nothing awaits us. And each version of this nothing will be different. So we'll do 3 drops. Option 1. It's better to do it from a great height or space. You take off on a jetpack into the stratosphere. You have a bottle of water in your hand. You pour out 1 drop. Let's say it starts accelerating itself. In this case, even at a low speed, a drop of water will burn up in the protective layers of the atmosphere. In less than a second, the drop will turn to vapor. Let's say our planet had no such protection as the atmosphere. The air resistance would still get rid of the drop. The drop is flying down at a tremendous speed. The cold wind turns it into an icicle. The greater the drop velocity is, the stronger the air resistance is. The drop is moving faster and faster, soon reaching the speed of sound. Then, it just smashes into thousands of small particles. Under such conditions, the drop will never be able to reach the Earth at the speed of light. Nothing happens because nothing gets to the target. The next attempt involves changing the drop. Oxygen, carbon dioxide, ozone, and other gases in the atmosphere destroy any falling object. But what if the drop didn't meet all these obstacles? You change the internal structure of water chemically. So, you put your jetpack on again and grab a bottle of water. At the height of the Earth's orbit, you open it and pour out 1 drop. It accelerates and there's no resistance. It passes through the hottest layers of the atmosphere, but doesn't burn, passing the freezing temperature, but doesn't freeze up. It flies to the ground, developing the speed of light, and crashes again. But nothing happens. The drop got the properties of a light particle, a photon. It's only under such condition that it might develop the speed we need. No object with mass, be it a car, a house, a tree, an ant, a single air, a grain of sand, or a molecule, can reach the speed of light. Only light particles are capable of it since they don't have mass. An intangible drop falls into the center of the target, and again, nothing happens. The third option. Scientists found a way to accelerate a drop to the required speed. They also have to change the molecular composition of water, making it more resistant to high and low temperatures. To make the drop reach the speed of light without any damage, you need to place it in a perfect vacuum. No air resistance, no protective layers of the atmosphere. We leave only space and the water. For this purpose, scientists need to build a long pipe. In the center of the Sahara, around the same target, people create a scientific center. From here, the pipe should go up. Its height is approximately the distance to the International Space Station. That's 254 miles, which is about the height of 50 Everest mountains. You can't connect to the ISS itself as it's moving all the time. It revolves around the Earth, completing one revolution in 90 minutes. That's why astrophysicists and engineers should build a small station designed for one person, and this station should move parallel to a single point on the ground. The vacuum tube is made of solid stainless materials so that rain and high temperature couldn't destroy it. Inside, it's an alloy of titanium and graphene, the most durable metal on Earth. The pipe is built horizontally. Then, with the help of several helicopters and cables, it's placed in an upright position and attached to a small space station. The pipe is equipped with small pumps that pump the air out and block its flow inside. The water drop shouldn't touch the walls, so there's a special layer of gravity plates. They push the water away from the pipe's surface, using the power of magnetism and sound waves. You put on a jetpack and fly to the station with a bottle of upgraded durable water. Your hands are shaking with excitement. Your breathing sounds loud in the spacesuit. You open the bottle, tilt it slightly, and pour one drop into a special box. Inside this container, the drop gets charged with the energy needed to develop the speed of light. Now it's ready for the journey. You look at the box, close your eyes, and press the start button. The drop flies into the pipe at a great speed. From the powerful blast wave, the entire station is thrown to the side. The drop accelerates, and at this point, the pipe made of the strongest metals on Earth begins to melt like ice cream. There's so much energy in the water now that it would be enough to provide electricity to a small city. And now the drop reaches the speed of light, which is 186,000 miles per second. The pipe turns to dust. It doesn't matter whether the drop hits the ground or not, because there will be nothing. Literally, all material objects, cars, houses, fields, oceans, computers, planes, ships, flowers, trees, should I go on, will disappear. Intangible things, such as gas, air, radio waves, electromagnetic radiation, billions of terabytes of digital information, all this will also be gone. Boy, are you in trouble. Any sound, shouting, music, the phone ringing, will be impossible to create and hear. The light will disappear, and then there will be complete darkness. But let's rewind time and see exactly what happened right now. It won't work though, because there's no time either. Imagine time as a stormy river that flows rapidly in one direction. Then this river falls into an endless pit and disappears completely. All this happened because a drop of water crashed into our planet at the speed of light. As soon as a drop begins to approach the needed speed, it loses its properties of water. It's now the most powerful and heaviest object in the universe. The energy that comes from it destroys everything for hundreds of thousands of miles. Concrete, ground, rocks, etc., 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 and on and on and on. Everything disappears. In the first second, it all gets shattered into millions of tiny pieces. Then these pieces are torn apart into millions of even smaller particles. The molecules burn up. Imagine a paper map of the world. If you wet it and tear it, it will turn into wet paper scraps. If you burn it, then part of the map will turn to ashes, and the other part will simply fly into the air in the form of smoke. The map will remain, but it will never look the same. But if you destroy the map's molecules, it's safe to say that the map never existed. There's no trace of its existence. The same thing happens to our planet. The energy coming from a drop of water makes the Earth never exist in space. And now the drop exceeds the speed of light. A black hole starts evolving. It expands and absorbs all the space debris. Then the Moon. Soon it will be the turn of Mars and all the other planets in our solar system. The black hole expands and increases the force of gravity inside it. Together with our planet, it absorbs light. It's getting closer and closer to the Sun. Our star splits into strips of light as if it had passed through a huge cosmic shredder. The sun explodes and spits out an impossible amount of energy. It's believed that black holes appear after the explosion of stars. Right now, all the solar energy is being absorbed by our black hole. It's getting pitch black. The light from distant stars falls directly into the supermassive infinity. Meteorites flying within a radius of hundreds of thousands of miles around are also devoured into the unknown. There are many black holes in space, but only one of them was created by a small drop of water. The higher the speed of any object, the heavier it gets. Mass is the amount of energy that an object has. When water molecules reach the speed of light, their mass begins to grow, and there are no limits to this. It becomes infinite. An infinite mass forms a black hole. It absorbs everything, and nobody knows what's inside the black hole. All that remains is darkness and the unimaginable force of gravity. So I'm guessing here that we probably should not be doing this experiment, should we? How about we make a baking soda volcano instead?
Asteroids flying around is sometimes like a fierce game of dodgeball, where you never know when some of them can go in your direction. So we can just track the situation and hope for the best. To figure out the risk, scientists from different organizations have to study the positions and paths of the asteroids that come close to our planet, especially those that are at least 0.6 miles wide. And the good news is that none of these asteroids will probably hit us for at least the next 1,000 years. Phew! To give us an idea of their power, scientists did an experiment to simulate the impact of such a gigantic asteroid. The energy released from the collision would be a mind-blowing 100,000 megatons. That's like detonating 15,000 tons of dynamite. Also, if such a big asteroid hit us, Earth would cool down significantly because of all that debris that would go into the atmosphere and block sunlight. Plants wouldn't be able to get their fuel in this case, so we'd all be in trouble, both humans and animals. Thankfully, such mammoth asteroid impacts are quite rare. The larger an asteroid, the longer it takes it to collide with Earth. For example, it's estimated that asteroids with diameters of at least 0.6 miles strike our planet about once every 700,000 years. And if we're talking about even bigger ones that are 3 miles wide, well, those are predicted to come crashing down only once every 30 million years. Yay! But hold on. Don't get too relaxed just yet. Astronomers focus on really large asteroids because those are the ones that can kinda doom our planet if they hit us. Yep, you got it right. In a dinosaur kind of way. Even if one of them didn't erase us completely, the damage would still be enormous. So, there are still some asteroids wandering around that we need to keep an eye on to see how they might evolve over time. Scientists have a model of tracking them where they focus on the parts of an asteroid's path that come close to our planet to see if the space rock poses a risk to us. And it seems there might be one asteroid, 7482, 1994 PC1, 3,600 feet in diameter that might pose some danger. It's supposed to come closer to our planet in the next 1,000 years. And when I say risky, it means there's a 0.0151% chance of it coming within one Earth-Moon distance. It already passed by us in 2022, but we were lucky because it was far enough 1.2 million miles. I'd say we can relax when it comes to asteroid scenarios. For now. Asteroids slamming into Earth would be new for humankind, but not for the planet itself. As I said, there weren't many of those big ones, but they still had enormous consequences. The first one that comes to most people's minds is, of course, the Dinosaur asteroid as big as a mountain that struck our home planet around 66 million years ago, near Mexico's Yucatan Peninsula. It was chaotic. Global firestorms and tsunamis were all over the place. Dust was blocking out the sun, and vaporized rock released sulfur, which then led to acid rain and the acidification of the oceans. But there was an even bigger fella that came before that one. Around 2 billion years ago, a gigantic asteroid crashed into our planet and left a massive crater in South Africa. The one we know today as the Redefort crater. And it seems this asteroid might have been even bigger than we all originally thought. Twice as wide as the space rock that erased dinosaurs. The Redefort crater is confirmed to be the biggest visible crater on Earth, with a diameter of about 99 miles. It used to be even bigger when it first formed, though. Maybe even 155 to 174 miles across. It's hard to figure out its true size because the crater has been eroding for the past 2 billion years. Think of it like slicing off layers from the rim of a bowl. The diameter gets smaller with each slice. When the asteroid, 7 to 5 miles wide, that wiped away dinosaurs hit Earth about 66 million years ago, It caused massive destruction. Forest fires, acid rain, tsunamis, and so much ash and dust that it changed Earth's climate. This all made about 75% of life on our planet extinct. The asteroid that created the Redefort crater was not only bigger, but it also traveled at a higher speed, which means the consequences there would have been even worse. But it happened a long time ago, and living beings were different back then. Maybe it was some bacteria that didn't even notice that something unusual was happening. Earth is not the only one. Lots of impacts have happened across our solar system too. For example, in our close neighborhood. Yup, moving to Mercury and its massive crater called the Caloris Basin. It measures about 950 miles across, which is more than the state of Texas. There's a ring of towering mountains around the crater which makes it look even more impressive. You can see different colors in the mosaic image of the Caloris Basin. They tell us more about the geology of the basin. The orange parts represent lava that once flooded the basin. These lava flows covered the original surface and added this specific orange hue. And after the lava flooded the basin on Mercury, smaller craters formed on top of the lava surface. These craters dug into the ground and uncovered the material hidden beneath the lava. Some of this material is blue in color. And this blue stuff could be a clue about what the original floor of the basin had looked like before the lava covered it. Venus, the hottest planet in our solar system, has a thick atmosphere that comes with a pretty good defense system against space rocks. It's so dense that it burns up most meteors before they even reach its surface. As a result, you won't see as many visible craters on Venus as on other rocky planets in our solar system. But Venus still has some scars that can tell us about some serious impacts that happened there. And one of the biggest scars we know about is Meade Crater. It's enormous, about 170 miles in diameter. The inner floor of this crater is relatively flat and kind of brighter than its surroundings. It's possible that the crater ended up filled with a mixture of melted rock after the impact, and maybe even lava from volcanic activity on Venus. Want to get an idea of what Earth might look like without its protective layer called atmosphere? Just take a look at the Moon. Its surface is littered with impact craters. This Tycho is one of the craters you'll easily notice on the Moon. When you look at the full moon, you can spot it as a distinct circle with bright rays that radiate outward, slightly off-center on the lower left side of the moon. This crater, 53 miles wide, has a beautiful central peak in the middle that's topped with an intriguing boulder. The size of this boulder is impressive. It would fill about half of a typical city block here on Earth. When talking about craters, we definitely can't leave out Mars. The red planet has a much thinner atmosphere than Earth. When spacecraft approach Mars, they rely on the planet's atmosphere to slow them down as they enter it. And indeed, the atmosphere helps slow spacecraft down during landing, but it's still not thick enough to completely protect Mars from all those space rocks that are coming all the time. From July to September 2018, a dark spot appeared on the southern pole of Mars. It consists of two distinct patterns. A theory says that the bigger, lighter-colored blast pattern can be the result of an impact shockwave scouring the ice surface. The impact generated winds that spread out and scoured the ice. The inner blast pattern, which is darker in color, occurred because the impacting object managed to penetrate the thin ice layer. As it hit the surface, it sent dark sand and debris flying.
Here's a riddle. Which U.S. city is so loved that its name should be repeated twice? You guessed it, New York, New York. But the thing is, how much of New York do we really know? I'm talking about the city that lies under the city. Dare to join me on an underground tour of the Big Apple? Then grab a flashlight. It's about to get dark. We'll start in the heart of Manhattan, in the front of the Romanesque City Hall building. Believe it or not, beneath our feet lies New York's oldest subway station, known as the Old City Hall Station. It opened in 1904 on October 27th, a night of true celebration for New Yorkers. People were so excited, some of them spent the entire night riding the trains back and forth. Before this, urban dwellers moved around in carriages pulled by horses. No wonder the subway was such a hit. You might feel like a time traveler stepping inside the Old City Hall station. The architecture is dazzling and one of a kind. They sure don't make subway stations like this one anymore. Fun fact, the Old City Hall station would cost $6.2 million if it was built today. Back in the day, it had dozens of brass chandeliers hanging around. It was one of the few spots in town with functioning electricity. And oh, not to mention brand new multicolored tiled arches and stained glass ceilings you can still see today. Impressive, huh? If you decide to wander down the tracks, you might be in for a treat. Underground New York is as fascinating as the city above the ground. But one thing we usually take for granted is the behind the scenes of what the Big Apple needs to function. Down here, you might see one or two of New York's pneumatic mail tubes. These tubes were built back in the 1800s and they were operational up until the 1950s. They were responsible for distributing people's mail through different post offices. Letters flew at an impressive speed of 35 miles per hour. That's almost as fast as a professional runner. It sure sounds like a useful system. But I have to say, it feels weird imagining people's correspondence flying around 15 feet underground. Back to street level. We'll wander around fancy Lexington and Park Avenues. If you look up, you'll see the famous Waldorf Astoria 5-star hotel. Many celebrities have stayed there, including John Lennon and Yoko Ono, as well as presidents such as FDR. This is why the hotel used a secret infrastructure to sneak people inside and out. Under the building, a tunnel known as Track 61 connected the Waldorf Astoria to Grand Central Station. The track was deactivated in the late 70s, but some people say Andy Warhol threw a party there in the 80s. I bet that was something. For the next part of our visit, we'll have to take the subway uptown. We'll get off at 125th Street and find ourselves on the scenic waterfront of Riverside Park. Here, you'll find abandoned tracks of an old metro line. If you follow the tracks, you'll get to an underground graffiti gallery, aka the Freedom Tunnel. The tunnel is named after a graffiti artist from the 80s who is commonly known as Freedom. While exploring these tunnels, we'll see over 40 graffiti pieces he painted over 15 years. There are spray paints of James Dean, Mona Lisa, and even a self-portrait of Freedom himself. Moving on, let's wander around the northern part of NYC for a bit. Walking in Van Cortlandt Park will feel like hiking upstate, but believe me, you're still in the city. Along the way, you'll encounter some big ventilation towers made of stone. These towers were once part of an old New York infrastructure. They make up the remains of what used to be the Croton Aqueduct. In the 1800s, the city's water supply flowed through a 41-mile-long underground tunnel, all the way from Croton River in upstate New York to Bryant Park in Midtown Manhattan. Oh yes, and I should probably tell you that Bryant Park wasn't a park. Instead, it hosted a colossal stone structure that looked pretty much like something ancient Egyptians would build. This 4-acre structure served as the city's water reservoir. It even had a pathway on top so that people could enjoy a nice afternoon stroll while looking at the reservoir's crystalline water. Now, all this exploring might have made you hungry, but don't worry, our next stop includes a yummy treat. We'll have to leave Manhattan and make our way to Brooklyn. In case you didn't know, New York City is made of 5 boroughs: Manhattan, Queens, Bronx, Staten Island, and Brooklyn. Crown Heights, that's our stop. Would you believe me if I told you that beneath these streets lie caves full of aging cheese? How very Parisian of them. To get down there, you'll have to make your way through a century-old building that now works as an office space. Maybe wave hello to all those hard-working people and disappear in one of the stairways that will take you 30 feet below the ground. You won't need a flashlight for this one. The caves are bright and renovated and can hold up to 22,000 pounds of cheese. But hey, it might stink. That's the main reason cheesemakers decided to use underground tunnels to age cheese in the first place. After a bite or two of some delicious cheese, let's keep going. While still in Brooklyn, you might see tons of locals enjoying a sunny day in the McCarran Park pool. This pool is a huge attraction, being 3 times the size of an Olympic pool. As the NYC explorer you are becoming, you might even go for a swim. But hey, there's a much more interesting part to this attraction. The pool was built in the early 1900s, but it was shut down in the 50s. During this time, urban explorers discovered a network of underground tunnels right beneath the pool. And, of course, you can find a secret entrance and get a peek for yourself. There, you'll not only see the pool's filtration and heating system, but also a lot of graffiti from the time the site was abandoned. Neat! This question may sound weird, but have you ever seen a cow in New York? I sure haven't. Well, maybe there's a reason for that. Apparently, New York still has underground tunnels that were constructed for the transportation of cattle. Once New York started to flood with automobiles, cows became a burden for traffic. Until a 200-foot-long cow passage was built below 12th Street to transport the livestock that was ferried over from New Jersey. These days, you won't be able to visit this place in person because the tunnel was most likely destroyed. But historians found blueprints proving its existence. To add to the list, archaeologists discovered a very peculiar fossil a while back. Now imagine peeling off the layers of the city's soil. First, at 15 inches, you'll find a layer of wires. I'm talking TV cables, electricity, and all that. Digging deeper, at 4 feet, you'll see water and sewage pipes. But then, at 15 feet down under the surface of NYC, diggers have found a fossilized shipwreck. The wreck is located right under Broad Street, where there was once shallow water. They believe the wreck dates back to the 1600s. It's 92 feet long and 25 feet wide. Oh, and that's not all. At the intersection of Bowery and Canal Street, engineers stumbled upon a room with its walls and ceiling covered in mirrors. And no one has managed to explain the existence of this bizarre place yet. Our Big Apple underground visit is coming to an end, but we sure did more than just scratch the surface on this one. Before we finish, let's enjoy the best of what NYC cuisine has to offer, a good old bagel. Who knows, maybe next time we'll do Paris or even London. See you soon, explorer!